So, doing a little more testing with this frequency drive, I have reconfigured the unit, just running the condenser fan here, but I've reconfigured the wiring to allow the capacitor to be in play, so I'm no longer running the motor on three-phase, simply running it on single phase like it's intended to do from the factory, and see how that operates the fan, if it still works. So we'll go ahead and give that a shot. So that's the motor starting at 34 hertz and still able to drive it up and drive it lower. Now I did notice that the motor will no longer start if you have too low of a frequency for a setting. I think maybe 5 hertz is about as low as it gets. So I'll let the motor stop spinning on its own and we'll see at what frequency the motor will actually start to drive while it's connected with its capacitor. So it's about stopped now. Give it another second, and just to rule out the inertia of the already spinning motor. Now you're also no longer able to reverse the rotation because you can't switch the windings that get the power first. So now it's stopped, and we'll go ahead and hit the run button, and we'll see at what frequency that it starts to spin. So I thought it was 5, but it looks like about 7 hertz has enough capacitance effect to give it the magnetism that it needs to start spinning the rotor. And then the other thing I noticed is I thought that it was driving, because I have the drive maxed out at 75 hertz or so, but the voltage stops increasing at 60 hertz coming out on the output of the motor, or of the frequency drive. So I don't think it's actually really spinning that much faster because it doesn't have enough power to do it. Because as you drive up through the range, along with the frequency, the voltage increases out of the drive as well, and it tops out at 220 volts at the 60 hertz mark. And without enough voltage, you no longer have enough torque to drive it any harder. And that's probably a limitation of the chipset of this particular drive. But with it being a cheaper drive, it's allowing me to do things that like an ABB or some other drive wouldn't allow me to do, which is send out single phase power. And the other thing that I noticed, and I'm going to test this on another motor, is that there is a feature where I can change the voltage output. So I'll put the fan at full speed, and then I will go ahead and change the voltage that is programmed, get into the data block. So it's set to 220, and I can reset it to 120. And then as soon as I come out of program, so it dropped the voltage. So now it's only putting out 120 volts, and you can see that the motor has slowed down. Well, it's because it ran out of torque at 120 volts, even though the frequency is still 60 hertz. because it takes a certain amount of horsepower to move that motor. If there was no load on it, it would probably spin full speed, but it has the load of the fan blade and the air that the fan is moving. So I thought that was interesting, and that gives me some more opportunities to test other motors. So I'll get back to it.